Hello guys, so in this video we are gonna discuss the Codeforces round 847 that was rated for Div3. So we'll be discussing the problems A, B, C, D and E. I haven't myself gone through like this particular problem, but this was related to trees and I thought it was a complicated problem, so there is no point in discussing this. If you are like already giving contest for Div3, solving these 5 problems definitely should be worth it, I guess, and they should definitely increase your rating as well with a great delta. So let's get started with the problem A. So the problem A is Polycarp and the day of pi. The problem states that on March 14, so this is some gibberish. Technically, I don't even read this kind of things. So I did directly get on to the point where important data is available. So over here it says that I'll just get you the gist of the question. So we'll be giving with some values, right? So for example, we'll be giving given with some strings. So this is a string given, then this is a string given, then this, right? So over here there are 9 strings that have been given to us. Corresponding to all of the strings, we have to tell them that what is the right value of pi, right? Or how many digits in this particular string correspond to the right value of pi. For example, the actual value of pi is this, that is 3.14152, all that stuff, right? So we have to tell that how many digits are correct. So for example, over here they have given a single digit, and we have to tell the number of correct values. So 3 is definitely the first digit, so we'll print 1 over here. Then the other string they have given is 000, so this is definitely not the first, this is not the the correct value of pi, so we'll print a 0 over here. Let's look at some other the test cases. So for example, for I guess, yeah, this test case, so the value is 31420. However, the actual value of pi is 31415, right? So for the because of that we can say that the value is wrong. So the like up till this point the value is right, so 3 digits are actually right, so we'll print 3 for this. Similarly over here all the 5 digits are right, so we'll print 5 for this, so on and so forth. I hope that you get the drill. So how do we do it? So you could think that you will firstly calculate the value of pi and stuff, but it's not required. They have actually given like the actual value of pi in one of the test cases, so this value is actually correct. And also they are limiting the number of digits up to 30, so this is a 30 digit string. You can see it from right from here, so you could have actually copied this into your answer and could have checked for the value. Otherwise you could have copied the real value of pi from the internet. I actually did that. So I copied the real value of pi, or the actual value of pi, then I started traversing my string till the time the value of pi was available, or the value of pi was right. At the first instance, where the value of pi was not right, I printed the index. So when I say I, since I'm talking about the zero base indexing, so I'll technically be printing the value of the correct string, or the length of the correct string. Else if I was able to run through the entire loop, that means the entire string was correct, so I'll print the value of the entire string. Cool. So this was a very easy problem. Cool. Doesn't even require much discussion. Let's move on to the second problem. So then also there's a lot of gibberish, so let me get to the gist of the question. So the gist is that, so this lady Taisa, I don't know how to pronounce his name, so she had n dice, right, and she rolled them. So now when you roll a die, so you'll be getting values from 1 to 6 on each die, right? Then she summed it up and the sum was coming to a value, let's say s. Now she removed the die, and the current sum now is actually r. So now we have to tell that what could have been the possible values on all the dice. So very intuitively, or very basic cases, that the die she removed would have a value of s minus r, right? Only then the new value is r after removing the die. So s minus r is pretty intuitive. What about the other dice? So let me get to the iPad so that I can share the solution. Give me a second. Cool. So if the number of dice is n, right, n are the number of dice, s is the initial sum I was having, and r is the final sum, or the sum I'm having by removing one die, right? So these are the die, let's say I have. So I can say that the die which was actually removed had a value s minus r. That is easy. So now I have to tell what are the numbers available on the other dice. So I have r dice, right, and sorry, I have n minus 1 remaining dice, and it has a sum r. Let me divide these two numbers. Now I can say that each of the die has a value r divided by n minus 1. But wait, it's possible that r is not exactly divisible by n minus 1, right? So let's say r modulus n minus 1, or the remainder you get when you divide r by n minus 1 is something x. Obviously x would be less than n minus 1. That's a simple rule of division. I hope you know that. So what I'll do is, in case I'm having x as the remainder, then for x of the remaining balls, or x of the n minus 1 dice, I'll add 1 to it. So what I'm saying over here is, for n minus 1 dice, so let's say these are the n minus 1 dice I'm having, they'll be having a value r divided by n minus 1. I hope that makes sense. However, x of them would have additional 1. So x of them would be having a value, x of them would have a value r divided by n minus 1 plus 1. This is the solution. Now technically you can actually add it up and check for the validity of it, but this proof was enough to validate that the answer would be correct. That's exactly what I'm doing in the solution 2. Let me show you the solution. Okay, let me replace it. Yeah, cool. Well, let's have a look at the solution. So initially I'm taking the three values n, s and r. Then I know that one of the die is the one that was actually removed. I actually wrote coins over here in the comments, ignore that. Then I'm taking a remainder, or you can say the modulus, that is r modulus n minus 1. That is the number of dies that are remaining, and on each of the die I'll be having a value r divided by n minus 1, right? Now for all the die I have to print the values, or all the n minus 1 remaining dies I have to print the value. So I'll check if the remainder is still something. In that case, I'm gonna print the value d that is supposed to be on all the dice plus 1, and I'm gonna decrement my remainder. Else I'll just print the value of d, and then I'll print a new line, and yeah, that's it for the question. So this was also easy question. Let's move ahead. This question is a bit tough, not like too tough, but yes, somewhat. So just a simple attention to it as well. So what the problem states is that you are having a permutation of n numbers. Then they've given the value of permutations. Cool. And now she wrote it like the lady or whoever they're talking about, she wrote it on a whiteboard n times in such a way that while writing the permutation at the ith time, she skipped the ith element, right? So when she'll be writing the permutation first time, so she'll be skipping the first element. Then when she'll be writing it second time, so she'll be skipping the second element. For example, if this is the permutation 4213, then when she writes it the first time, so she'll be writing 213. So she'll actually be skipping the first element. Now when she'll be writing it the second time, she'll be writing 413 by skipping the skipping the second element. When she'll be writing the third time, she'll actually skip 1 and she'll write 423, and so on, right? So this is the deal that they're gonna do. At the end we have to tell them, so they won't be telling us the actual permutation, but they'll be telling us this, that what she actually wrote in each of the iteration, and then finally we have to tell them what is the value, or what is the actual value of the permutation. So then they have given the test cases. I won't be going into much detail because there's an easy intuition to it and a pattern you can easily see. So over here you can see that you are able to see 4 in 3 numbers, right, or in n minus 1 numbers, but in one of the number 4 is not available. Now what does that tells us? Now since we know that each element is absent, like each element would be absent in only one row, right? So that means that in this particular row the first element is absent, that was actually present in the other rows. Cool. So with that we can say that 4 actually is the first element, because it is present in one other rows and it's only absent in one of the row. So 4 definitely is our first element, and since over here the fourth element is absent, so that means the zeroth element or the first element was removed, right? So that means this is the remaining part of the permutation. Now we also know what the first element is. The first element is 4. The remaining permutation, or the elements from second onwards, is 213. So we can simply give them a value 4213. Let me like make you go through the solution itself. Maybe it becomes more easy to understand then. Cool. So over here I'll be having n values, wherein n minus 1 values would be there in each of the rows, or in each of the permutations written, such that one of the values removed in each iteration. Then I'll be calculating the value that is available, the value that is available at the first index. This I'm doing so in order to check what would be the first element available to us, right? Then I know that if my f is greater than 1 or if its frequency is greater than 1. So in our case over here we saw that for the first element, right, its frequency would be greater than 1, right, or its frequency would actually be n minus 1, right, and in one case its frequency would be 1 itself. So in the rows which has like the digit which has a frequency n minus 1 when it's present at the index 1 would definitely be the first digit of our permutation. So that's what I'm checking over here. If frequency is not 1, or in other words I could have actually written over here if frequency is equal to n minus 1, in that case that definitely is my first digit. So I'll set it as my first digit, I'll print it and I'll break through this loop. Then I'll check for any permutation such that the first digit is not 4. So there's only one permutation in which the first digit wouldn't be 4. This is this one, right? So this is the remaining permutation I need. So once I find that, I'll simply print that up and then I'll break and I'll print a new line. I hope this was also really easy to understand. If it's not still not clear, what I'll advise you to do is that write it down on a piece of paper and try to understand that why this is happening. I'm definitely sure that you'll be able to build your logic, and in this way even you, like your understanding of the things and your way of tackling things would definitely improve. If you still have a doubt, you can let me know in the comment section or on my Discord, but I really hope that you will be able to do it if you follow this particular strategy. Cool, let's move on to the next problem, that is problem D. This also is an easy problem with a lot of ways to tackle it, but I was using a certain way that is easier to code. I'll try to teach you that as well. So what it says is that there's a wooden toy in the form of a painted doll, right, inside which you can put similar dolls of a smaller size. However, the constraint over here is that let's say the current doll size is S, then inside it you can only put a doll of size S minus 1, right, and inside that you can only put a doll of size S minus 2, so on and so forth, right. So in this way you had multiple toys, and in multiple toys you could have actually in one of the toy you could have like S dolls and like uh, you could have X dolls, in other toy you could have Y dolls, and so on and so forth, right. Now you like brought the doll out of the toys, so you have like kept them individually, and you know the number of dolls you are having at the sizes you are having, right. So that's what it is. Now we have to tell them the minimum number of sets that you can initially have. One more thing, that when I'm discussing the solution I tend to avoid reading this entire problem statement in order to save time, but in case you have not read the problem statement yourself, what I'll advise you to do is firstly go to the problem statement, try to read it, and then try to come back to the video if you are not able to solve it, or if you need a better understanding for that. Only in that case you would actually improve. There's no point of watching this video if you have actually not even read the problem statement. So that is something I'll advise. Cool. So I think the problem statement was pretty clear, there was no doubt over that. Then we have to print the minimum number of sets, right. So how will we do it? Now there are multiple ways of doing it, but let's test a very easy way. So what I'll do firstly is that I'll sort it, right. Let's take example also so that it's more clear. So over here I'm having a value 2 2 3 4 3 1, right. So this is the value that I have, 2 2 3 4 3 1. So I'll firstly sort it, 1 2 2 3 3 4. Cool. Now I'll maintain a frequency. So 1 has a frequency of 1, that's cool. Then 2 has a frequency of 3. I'll just write it like this. 2 has a frequency of 2, sorry. 3 also has a frequency of 2. 4 has a frequency of 1. Now let's try to draw this in a line chart manner. So this is my x-axis, this is my y-axis. This is my x-axis, this is my y-axis. The x-axis basically means the size of the doll, right? And y is the frequency count. So for 1, the size is like for the size of the doll 1, I'm having a value 1. For the size of the doll 2, I'm having a value 2. For the size of the doll 3, I'm having a value 2. For the size of the doll 4, I'm having a value 4. So this is this kind of a scenario I'm building, right. So I anyway have to, like, this is the graph and this is what I'm able to build from this, right. So this is what I'm building. Cool. So what I can say is that initially I'll definitely have to start with some dolls, right. So when I'm standing at the location 1 or at the size 1, I'll have to start over there itself. So I have to say that this is actually the number of dolls that would be new sets, right. So one new set definitely needs to be created. What next? Now let's travel to the next element. Next element says that my size is actually 2, right. So if you started creating a doll with one size, right? So initially, if let's say the previous doll was of size 1, now in order to get a doll on top of it, you can have a value 2, right? But the frequency of that was only 1. So over here you can see that there was there was a spike up. Let me change the color. So there was a spike up over here, right? Now what you will do is that you will say that, okay, what was the value of the spike? So the value of the spike over here was 2 minus 1, right? So I'm talking about the y axis over here, or the frequencies you can say. So one frequency increased. So now one of the doll can be utilized, that was of the previous size. One more doll needs to be added, that would have a minimum size of one more set need to be added, which would have a minimum size of 2, right? So I added 1. So over here this is the number of sets I'm making, so I added 1. Now I go to the next element. Now I say that its frequency is similar to the backwards one. So now it's fine, I can actually continue with the same. So I already have 2 sets which are having a size of 2, right? So for my size of 3, I can utilize those 2 sets. So basically what I'm saying is that these are the 2 sets I'm having, right? Okay, and also they have a size of 2. Now I have 2 dolls of size 3, right? So I'll place these dolls on top of it, right? That is something I can do. So cool enough, I'll not increment anything over here. Now I'll go to the other next point. Now at the next point I'll see that now I'm having a value that is 4, right? So 4 is fine, so I'm not worried about the value, because actually 4 is just greater than 3. That's also fine for me. Now I'll check for the value. So the previous value or the previous frequency was actually 2, right? Current frequency is actually 1. So 2 is greater than 1. So what I'll say is I just need 1 doll, right? So 1 doll of size 4 I have. So I can place this particular doll on any of on top of the previous sets, any of the 2 previous sets, right? So that's also possible. I need not increment my size by 1, right? So my final answer is 2. Now let's try to check it if the value is correct. Yep, so the value is correct. Now there's one edge case that you need to see. Let's say the frequency 3 was missing, right? So in case my frequency 3 was missing, so let's say 3 is missing from here. Let's remove it. So if I remove 3, then what happens is that for 4, I'll say that the previous value is not present. So 4 would be looking for a value 3, right? It would say that no doll of value 3 is present. In that case, it will say that the number of dolls for value 3 is actually 0. And now since I'll have to start a new set, so I'll have to add I'll have to increment the number of sets by whatever frequency is there for 4. So over here I would have added the value 1, right, if that was the case, because the frequency of 4 was 1. Cool. So that's it. That's what I wanted to explain. Also one more thing is that this particular thing or this particular logic is applicable at a lot of places. So when you want to find the minimum number of sets possible or some things of this sort, drawing it graphically actually helps a lot sometimes. Now I'm not saying this is the only solution. There are a ton of more solutions that you can actually use. However, this one definitely is one of the easiest to code and easier to comprehend as well. Okay, so let's look at the code also. The code is fairly simple. Cool. So the code says that firstly I'll sort the array, right? So once I'm done with the sorting of the array, what I'll say is that I'll store this values this values into vals, that is a map. Now the reason for taking a map is that the keys are already sorted in a map in a ascending to descending fashion, ascending fashion, right? That's what I actually require. So that's what I'm doing over here. Now I have taken some variables. You need not take it. I was testing something else, so you need not take this. Then you can start traversing through your map. Then you can say if the first if the value is the first element, then you'll simply add this frequency. You can actually code it up in a better fashion. You can simply check if the previous value is not available, then you'll simply add its frequency. But anyway, never mind. Or even I could have started from here itself. Even that would have made sense. No worries. Cool. Else what I'm doing is if it's not the first value present in the map itself, in that case I'll say that my p, or I'll take a previous pointer, because I need to check the previous value as well. So this is how I'm taking the previous pointer. Cool. Then I'll check if the current value is just one more than the previous value. In that case I'm in a continuity, so the value I'm gonna add to my result would be either 0, so I'm gonna add nothing, or so the reason I'm checking a max over here is so that in a case where the previous frequency had a greater value and the current frequency has a lower value, I don't decrement my result, right? So that's the only reason for taking a max over here. So when I'll be done with this, I'll say that it second. So it second basically here means the frequency of the current element minus the frequency of the previous element. So I'll be adding that. In case the continuity is not maintained, so in that case I'll be adding the frequency of the frequency of the current element or the total frequency of the current element. At the end I'll be printing the result. Cool. With that, we can move on to the last question that we are going to discuss. So that the question's name is Vlad and pair of numbers. So the question states that there are two numbers a and b, right? I actually like this problem statement, it's pretty short. So the problem statement is that there are two numbers a and b, and then a XOR b is equal to a plus b by 2, right? So now we are only given with a XOR b. Now we have to tell that if it's possible to build, if it's possible to have two numbers a and b such that this inequality or this equality is maintained. If it's possible, then we have to print the values of a and b. If it's not possible, then we have to print -1. Cool. So a pretty short question, I say, and let's try to find what we can do is. So the equality that we have is a XOR b is equal to a plus b by 2. Right. Now what's happening over here? When we do a XOR, if you know, so a 1 0 gives us a 1, right? A 1 1 gives us a 0. A 0 1 gives us a 0, or 0 1 gives us a 1, and a 0 0 gives us a 0, right? However, the value of a XOR b is definitely not less than a plus b, right? From this equality that we can say. Now let's check what happens for addition, right? So a 1 0 would give us a 1, a 1 1 would actually give us a 1 0, right? So it's actually doubling it. Now a 0 1 gives us a 0, gives us a 1, and a 0 0 gives us a 0. Cool. So from this you can say that the value that is gonna help us over here is, because these operations are technically same, right? So the values I'm gonna get for these operations is same. The only difference is that when I get a 1 1 in case of a XOR, I get a 0. However, when I get a 1 1 in case of a or in case of a addition, then it get a 1 0, right? So this is something I can utilize. But how can I utilize this? Now let's say my a XOR b is something. Now let's say it's 10, right? 10 in decimal format. So what's it in binary format? It is 1010. Cool enough. That's pretty simple to understand, right? Now what if okay, so let me try to make it more simple for you. So since I'm having to divide it by 2, right? So what I want is that a XOR b is equal to a plus b divided by 2, right? So since I want that the addition should be double, or you can say a plus b is equal to 2 into a XOR b, right? So that simply means that whenever I am having a 1, right? If at the previous location I have a 1 and a 1 also, right? So by that what I mean is that let's say this is the number 10, right? Now this is the number 15. Cool. So over here you can see the thing with like 10 and 15 is that in 10 I'm having zeros after a 1. I've copied those 1 as it is, and after each one I have like added a 1. So let's say this was the number. Cool. In this case also the remaining number I'm saying is would be 1100 Now why I'm doing that? Because what I want to do is that whenever I'm having a number 1, I want that the previous number or the previous digit to it, that is 0 in this case, should be 1 also. Now why is that? Because if the other number I'm having also has the same parity, so over here if let's say this is the number a I'm saying, this is the number b, right? If it also has the same number, same ones, right? Over here this was the original one and this is the one I actually added, so I'll also make this one, right? So whatever number I'm saying, in this case what would happen is that when I'll add it up, right, so this would become 1 0 obviously. However, when I'll take a XOR, this will directly give me a 0, right? Or in other terms what's happening is that when I'm adding it up, right, I'm actually making its value double. So now it has a singular effect over here, but as soon as this value is actually added, so on adding it up, the value would become double for this. However, when I'll be XORing it, then this value would give me a value 0, so it won't change this. I hope that's making sense to you. If it's not making, try to like write this down once on your own. Try to understand what I'm saying over here. Cool. So I'll reiterate it so that you are able to understand it, that if you're having a value 1 or you are having a digit 1 in the binary notation, right, then it will be written as it is. However, if just to its right you are having a digit 1, and in the other number also you are having the same having a digit 1 at the same index, then what would happen is that when you will be XORing it, then it would get a value 0. But when you will be when you will be adding it, so when you will be adding it, it would give you a 1 0, right? So 1 technically would go over here, right? On other terms, it would make its value double. Cool enough? So only in that way the entire value or the entire number can be made double. I hope that's making sense now. So with that, what I basically have to check is that whatever the XOR value I'm given, right, I'll write it as it is. So let's say this is the XOR, just a random XOR value that I'm saying. This is the XOR value that comes out to me. This is the binary notation of the XOR value, I'll say. I'll have to check that after every one, do I have a 0? If I have a 0 after every one, well and good. If I don't have a 0 after every one, then I cannot perform this particular trick, right? If I'm not able to perform this particular trick, my answer does not exist. But if I have a 0 after all of the occurrences of 1, in that case what I'll say is that my number A would actually be 1, and then I'll make the first 0 to the right of it as 1 as well. So it would be 1 1 0 1 1 0 and 1 1, right? And B would actually be, or in other terms you can say that it would be A minus this, or just the extra ones that you have added. So these are the extra ones you have added, right? Cool. This would be your B. Now when I'll AND it up, or when I'll XOR it, so on XORing I'll get a value. So this is 1 0, this would be a 1, this is 1 1, this would be a 0, this would be a 0, this would be a this would be a 1, this would be a 0, this would be a 0, this would be a 1, this would be a 0. That is exactly the value of A XOR B, right? From here you can say this was the actual value that was given, this is same to this. So that's fine. When I'll AND it up, what I'll be getting, let me erase it and write it over here itself. So when I'll AND it, what would happen is this 1 is over here. Okay, so yeah, this one is over here and this one is over here. They will actually give me a value 0 and a 1 carried. So this will also become a 0 and it will give me a 1 over here, right? Cool. For this, okay, so this is covered. For this also same thing would happen, 0 carried over 1, this would give me a 0 carried over 1, this would now come out to be a 1. Now this would give me a 0, this could give me a 1, right? It will get ANDed again, and this is the value I'm getting, right? So this is the initial value. Let me copy this and bring it down. Cool. This was the initial value and this was the final value. So this was actually A XOR B and this is A plus B. Now you can see this technically is shifted by one place to the left, or in other words A plus B is equal to 2 into A XOR B. I hope the proof is clear. If there are any doubts, you can definitely let me know in the comment section, but I really hope the explanation was lucid. So let's look at the code. The code is fairly simple for this. So the code is that okay, so I have used some functions over here. You can do it in a single code if you like. I just like to do it in this manner because it means more readability. So firstly I am taking a value n, right, or the number that is provided, that is A XOR B. Then I'm converting into a string. So my convert method is over here, right? Yeah. So my convert method basically makes the string and basically makes the number into a string. So once I'm done with that, then I check if it's a valid string. So the reason for the check for the valid string is that after every one I should be having a 0. So if it's not a valid string, so the valid string logic is actually over here. So I'm just checking that the last value should not be a 1, because if the last value is a 1, I don't have any zeros to the right of it, obviously. In that case I can directly print a 0, or I'll be checking if the current value is 1 and the other value is also 1, right? Then I'll return a 0, else I'll return a 1. So if it's not valid, then I'll be printing -1, but if it's valid, then I'm using a function getAb. So let's see what getAb is doing. So getAb initially gets the string that I'm having, then it makes two strings A and B. So the reason I'm making two strings is because it's easier to do. You can actually make the two numbers uh, itself, but that's what I'm doing. It's more readable as well. So if I'm getting a 1, right, then I said that in the number A, the same character should be appended, but in both of the numbers A and B, the next character to it or the character just to the right of it should actually be made 1. So that's what I'm exactly doing over here. Then I'll be getting the strings A and B. Then I made a method getNums. It's doing nothing, but it's just converting the value from strings to an integer. So then I'm returning the two values A and B, and then I'm printing them. Cool. So this was the solution for this. If you have any doubts in any of those explanations, please let me know. I'll definitely help you out over that. Cool guys, thanks a lot for watching this video. Bye bye.